Okay, a circle is a set of all points equidistant from a given point in the middle. This point A in the middle is called the center of the circle. That's not hard, right? It's called the center of the circle. Okay? The center of the circle. What's this segment from the center extended out to a point on the circle called? Good. So that's the next point. A radius is any segment with endpoints that are the center of the circle and the other endpoint is on the circle. The plural form of this is radii. R-A-D-I-I. Radii. Okay? Next picture. A segment with endpoints both on the circle. So, endpoint and endpoint. Both endpoints on the circle is called a chord. Okay? There's one special chord that goes perfectly through the center of the circle. What's that called? Diameter. Good. The diameter is a chord with both endpoints on two opposite sides of the circle, but it runs through the center of the circle. Okay, so that's probably all the information you've learned at least once in your life. Hopefully now you remember what a chord is, and the other ones you should already know. New one, an angle inside of our circle, but the vertex is at the center of the circle. This is called a central angle. Central angle. A central angle, don't flip it over because we're going to have something at the bottom. A central angle extends to the circle, but the key point is the vertex is on the center of the circle. Don't flip it over. We're going to add something at the bottom. There's an interesting relationship that happens with this central angle measurement compared to the arc that it curved the way I wanted it to. Let's try it anyway. This arc that is on the outside where it intersects the circle, it creates this arc. We have two arcs actually. This yellow arc is a minor arc that's small. The black arc on the outside, that's a major arc. Okay? So the minor arc, the black arc, the rest of the way around the circle is the major arc. This yellow arc, the minor arc, has a relationship to the measurement of angle A. Write this down at the bottom of your page. The measure of a minor arc, the measure of a minor arc is equal. Is equal to the measure of a minor arc is equal to the measure of its corresponding central angle. Okay, the measure of a minor arc is equal to the measure of its corresponding central angle. It goes on the bottom of that front side of your packet. Okay, so if I told you that the measurement of angle A was 40 degrees, what would the measurement of this yellow arc from B to F be? 40. Yep, they're equal. That's pretty easy, right? Okay. Yeah. Flip it over. Now we have a different type of angle. If the vertex of this angle it located at the center of the circle? Is the vertex of this angle inside located at the center? No. So the vertex is moved. When the vertex is on the circle and extends to two other points on the circle, it's no longer a central angle. Notice the angle is on the inside of the circle. We have a word for that. We learned before. It's called inscribed. Okay? This is an inscribed angle. Inscribed angle. Okay? When it's on the inside, completely on the inside, with all the vertices, or in this case, all points on the angle, or on the circle, but it's on the inside, that's inscribed. Okay, this also has a relationship with the arc it creates. D to C. Anyone want to take a guess? The relationship angle B to its arc DC. Do you think they're equal?
Yes.
Remember, this one was equal. Are those the same? This central angle, is that the same measurement as angle B?
No.
Is angle B bigger or smaller?
Angle BC is smaller than angle BB.
Angle B is actually smaller than angle A. It actually ends up being a half. The red one, angle A, is congruent to the yellow arc. They're the same measurement. But angle B, the measure of angle B, our inscribed angle where the vertex is no longer at the center of the circle, is half the length of the arc DC, or the arc is twice. So the arc is twice the length of the angle's measurement. Okay? So I told you angle B, excuse me, measured angle B was 40 degrees, and we know this is an inscribed angle where the vertex is on the circle. What was the measure of the arc DCB? Okay, good. The arc is just twice. Johnny, you have that written down? You know what to? Okay, next box, a polygon. Notice where the polygon is, and every vertex is on the circle. Is the polygon on the outside or the inside? It's on the inside. So the polygon is inscribed, the circle is on the outside. What was that word for outside?
Exterior.
We did this when we were doing constructions of medians and altitudes. We have inscribed on the inside, and we have circumscribed. Circumscribed was that same one. Circumscribed is the word we need today. Okay? A polygon that is circumscribed, circumscribed by a circle. Circumscribed by a circle. We're going to have to squeeze that in. The blade's not really big enough. And a polygon that is circumscribed by a circle because the circle is on the outside. Circumscribed goes all the way around on the outside. And let's look up, please. But the vertices touching every vertice is on the circle. Okay? A crater-shaped solid completely enclosed by the figure is, or this solid is, on the inside. So the solid on the inside is not circumscribed, but it is, what's the other vocabulary word? It's on the inside. Inscribed. Inscribed. So the circle is circumscribed, that's on the outside. And the quadrilateral is inscribed, because it's on the inside where each vertex touches the circle. Okay? A line that intersects a circle only at one point See this line that keeps going because of the arrows? It comes up, it hits the tip of the joint, and brushes right off. It only intersects once. What type of line only intersects once? You've probably heard this before. Starts with a T. And it's actually already in the box if you read down further. Yep. Read the box. BC is tangent line. Okay, a tangent line, a line that intersects circle on only one point is a tangent line. Okay? That one point where it intersects the circle, that is called the point of tangency. Point of tangency. Okay, we're going to add something in this box that's not here. If I connect that point of tangency to my center of my circle, what is this blue thing that I just drew? The radius. Yep. Okay? And it so happens every tangent line, tangent touches at one point, tangent lines are always perpendicular to the circle right at that point. So this radius to our point B, point of tangency, and the tangent line are perpendicular to each other. Always. Okay, Johnny? Okay, like I say, we're going to add this to the box. A tangent line is always perpendicular to the circle. And that 90-degree angle usually is not drawn in for you. You should know that it's a 90-degree angle and draw it in yourself. Okay? Last one on this page. A line that intersects the circle in 2 points. This is not a chord. A chord starts and ends on the circle. But this line keeps going forever. That's what a line is. It has these arrows. So a line that continues through the circle and continues going is not a chord, but what instead? It's down at the bottom. A secant, that's how you say it, is a secant line. Okay, don't flip it over because we're going to add one on the bottom that's not here. So, a quick review about our angles that we talked about. On the front page, this central angle where the vertex is in the center of, hey, you. There you go. Connor, you know what face is it? A central angle where the center is on, and where the vertex is. This angle has what relationship to that yellow arc it creates? They're equal. So this angle was 55 degrees, Johnny. What would the measure of the arc be? If the angle is 55, and if the central angle is the vertex of the center, then the arc is 55. They're equal. It should be the same number. No. And everyone else is here. Now, on the second page, we look at a different angle. When the vertex moved, and it was over here, at B, and if angle B was 60, what's the measurement of its arc? Okay? Twice, so that would be, yeah, so if it's 60, then twice of 60 is 120. Good. Okay, so when the vertex moves, and its arc gets bigger, and the angle is smaller. So if I say this arc is 100, then the angle would have to be 50. This is a different angle. The vertex now is on the circle instead of in the center. Okay, so we've done an angle where the vertex, Connor, you gotta focus this way. You two will stop poking each other. This vertex, we've done it at the middle, we've done it on the circle, and now we're going to put the vertex outside. Okay, so that's one we're going to add on the bottom. What was that word for being on the outside again? So circumscribe. So this is a circumscribe. Just add this to the bottom. There's a little space there. Angle. Okay, a circumscribed angle is an angle where the rays are tangent to the circle. Is an angle whose rays are tangent to the circle. Is an angle whose rays are tangent. And to be tangent to the circle, you need to be on the outside. So we're going to draw a picture. As best you can, draw a large circle. That's not too bad. From the center point. Okay? Zach, what do you want to call the circle? Give me a letter. T. Okay? Capital T. Okay? We have an angle circumscribed to the circle, which means both rays of the angle have to be tangent to the circle. So if I draw a tangent line, that was a little too close. Tangent line must hit only once to the circle. There's the vertex of my angle. I'm going to now do a tangent line down here, so it only hits once to my circle. Creates 2 points of tangency. One, can you give me another? Actually, one, give me 3 letters. F. 2 more. Okay? And L. Make sure they're capital. So we have angle FCL. That's a circumscribed angle because it's on the outside. It touches the circle exactly twice. Because CF is a tangent ray and CL is a tangent ray. Now, we want to talk about the tangent lines. Tangent lines have a special intersection with the circle. So they what's that degree that the CF intersects the circle TF? What? CF intersects the circle at a special degree. 90. So, other than 90 degrees perpendicular, same with CL, 90 degrees. You know that the tangent lines, you know you have perpendicular intersections at that point of tangency. Something else interesting that happens is this segment F to C will be congruent to the other segment C to L. Connor, take the jacket off your eyes. Turn around. Put the jacket down. Right, Connor. Put the jacket on your back, please. Slide it. Right. 2 interesting things that happen here. The segments, the 2 tangent segments, will be congruent. Johnny, write this down. CF, that tangent segment, is congruent to, who can tell me the other segment? Okay? CL. I put parallel. That's not supposed to be parallel. Congruent is the symbol I need. to CL. Okay? Now, as far as the measurement of angles go, angle C has a relationship to this minor arc. Remember, the minor is the smaller one. We also have a major arc on the outside. This teal part, more, is a major arc on the outside. So when we have a circumscribed angle, angle C, the measure of angle C ends up being half the difference of our major arc subtract the minor arc. But in order to name these arcs, I need two more letters because if I just name the arc, the major arc TL or FL, I don't know which way I'm rotating. If I rotate to the left, it's the major arc. But if I rotate F to L to the right, it's the minor arc. They're two different arcs. So I need two more letters that we haven't used. D and what? N as in Nancy. Okay, I'm going to put D right here, and N as in Nancy right there. Okay, so now with the third letter, we can know the direction of rotation. Our major arc is F, D, L. So F, D, L, that's our major arc. We're going to subtract, so this is the major arc. We're going to subtract the minor arc. The minor arc is F. What's the next letter on the minor arc? I don't know if he's here. Is there a kid out in the hallway? F. What's the next letter? N, and the next letter? L. F, N, L is the minor arc. Okay? So, if we knew that this major arc was, say, 106 degrees, we could find the measure of angle C. Do you know how many degrees is monthly rotation in a circle? 360. 1/8 is just a half rotation. So, knowing, actually, we probably shouldn't do 106 because that's more than a half semicircle. Maybe I should make this bigger. Well, how about 190? That's probably more accurate because there's 180 and then a little bit more. Okay, so 190 degrees is our major arc. We know that a whole circle has to add up to 360. So please calculate the minor arc, this yellow part. Yep. How do you find 170? Yeah, you just take 360, subtract 190, and you get 170. Okay? So, knowing both those arcs, we can calculate the measure of angle C. The measure of angle C would be half the subtraction of the two, or the difference. 190 minus our minor arc, 170. What is 190 minus 170? 20. So half of 20. Half of 20 is 10. So our angle would be 10 degrees. Okay? Okay, flip it over. We're almost done. And then we'll do extra credit. Here, hold on. I think this one I have to open up separately. Okay, everyone do a quick stand up and stretch break while I'm opening a new document. Okay. Nope, only one person at a time. Well, I shouldn't have. No, only one person was allowed to go. Who else just left? Connor, Slough. Who else just left? Braden. Braden was the one that asked? Okay, I guess it's Hunter then that left.
Hunter asked. And I was like, oh, Hunter.
Who is in the front here? Oh, okay, that's just your stuff. Okay. Everyone have a seat? Okay. At the top, let's just re-emphasize these two little terms we just went over. Central angle, remember that central angle has the vertex at the center. The central angle and its arc are, give me one word to describe the relationship. The central angle measurement and the arc measurement are equal, congruent. Okay, either one of those. The measure of an inscribed angle has the vertex on the circle. The measure of the inscribed angle compared to its arc. The angle is half, the arc is twice, right? Cool. Alright, now we're going to convert to radians and degrees. Remember how we've been using degree mode on your calculator? Yeah? Well, there's also radian mode. You'll really work with more next year, so I'm going to just give you a super brief introduction of what radians are. You don't have to get all this, just pay attention. Okay. I need something bendable. On a circle. Right. One rotation is 360 what? Degrees. So if I start here, and 0 degrees, I'm going to do all the way around, and end at 360 degrees. That's in degree mode. In radian mode, every degree has a radian equivalent. So I have the keys out, so I have something bendable. I'm going to measure a radius with my keys. So I'm going to fold it around the circle, and we're going to see how many radii fold around the circle. Okay? So, I have approximately 1, 2, 3, 4, 5, 6, and how much? 6.28 actually. Connor, stop calling for and you and Brendan. I think you guys permission to leave. In the classroom. Well, here's the only guy. Here's the only guy who had permission to leave the bathroom. Connor, you already left once, so I don't know why you need to go there. 6.28, okay? No matter which circle you have, if you take the radius and you perfectly bend it around the circle, not loosely like I was just doing, you perfectly bend it around the circle, it will perfectly bend around the circle exactly rounded 6.28 times. 6.28 looks familiar? 2.14 times 2. So it takes 2 pi's to go around. So at 0 degrees, you're at 0 pi. Rotate all the way around 360 degrees is 2 pi. So if we're only about halfway in degrees, that's 180. But in pi's, if one full rotation is 2 pi, what's a half rotation? 1 pi. Okay? These are called radians. When you have the the relationship of how many radii bend around the circle. That's your quick review, overview of what a radian is. You'll really use it more next year. Okay, so we're going to quickly learn how to convert back and forth between degrees and radians. We're going to convert 50 degrees to radians. Radian is a pi in it. Now, who's taking my chemistry science class? Okay, a couple of you. In chemistry, who's taking chemistry? In chemistry, you in physics, you work a lot with units and unit conversions, and you want to cancel units. In order to cancel units, you have to have the same unit on top as you do on bottom. Connor, get your pencil, please. In your hand. So here I have 50 degrees. If I want degrees to cancel out, I need a degree on the bottom. The easiest degree to use is 180 degrees. If I have a degree on the top and a degree on the bottom, the degree unit will cancel out. So this degree cancels with that degree. The 180 has a radian equivalent. How many pies did we say it took to get around halfway? All the way was 2. Half was 1. So pi over 180 is actually a fancy form of 1, because pi is equivalent to 180 degrees. Yep. So the degrees cancel out, leaving a pi. So we're now in radians. All you have to do with your calculator is do not type in the pi. With your calculator, type in, please, 50 divided by the 180, and we're going to simplify it. We don't want the decimal. Connor, you have to find a way to sit in your chair. Now find a way to sit in your chair. 50 divided by 180. We want this as a simplified fraction. Who knows how to simplify in your calculator? Yeah? Good. Math. Enter, enter. Everyone do that? I determine what's the fraction you just got. 5/18. So our radian is 5 pi 18. You do not type the pi in your calculator. You get a simplified fraction. 5 over 18, and then you just put the pi in the numerator. That's a radian form. Let's try this example 1 down below. Converting 135 degrees to radians. Oh my heavens, folks. I'd like to be able to give you an extra credit, but we have to get to it, so stop messing around. Okay, I have a degree right here, so I need a degree on the bottom. What's my degree I should put on the bottom? 180. Technically, you can use 360, but then you're dealing with 2 pi, so you have to simplify. So 180 is the easiest one to use. I put the degree so that I know my degree units cancel out. What's 180 is equivalent?
2 times pi.
It's only 1 pi. Okay, then we do your calculator. We do not type the pi button. We just type the fraction. 135 divided by 180. Math. Enter, enter. Hunter, type that in, please. 135 divided by 180. Math. Enter, enter. You calculate. Calculator's up here.
You don't even know.
Okay, Gerardo, you calculate? Would you got that one already? What's the fraction? Good. Okay, so Gerardo got 3/4 squares. So we did 3/4, we just fixed the pi with the 3. So it's called 3 pi fourths. That's the radian equivalent. What? 135 will always be 3 pi fourths. Okay, now we're in reverse. Now we're going to start with radians and go to degrees. The radian I want to do is 7 pi fifths. I'm going to convert 7 pi fifths to degree. Then we have to cancel units. So if I have a pi on the top, how am I going to cancel that pi? Because if I'm in degree, I shouldn't have a pi anymore. How do I cancel the pi if I have a pi on the top? I have on the bottom. So we're flipping our fraction this time. Pi's on the bottom, but what's on the top? What's the degree for pi? 180 degrees. The pi comes out, and it leaves just the degree. In your calculator, you should do parentheses 7 divided by 5 times 180. Okay? And again, we don't type in the pi button. Parentheses 7 fifths, when you put fractions in parentheses, times by 180. What do you get? That's already here. Okay, that's how you go back and forth between radians and degrees. you need to make sure if you have a degree, then you have put 180 degrees on the bottom, so it cancels out. If you have a pi, you need to make sure you put a pi on the bottom, so it cancels out. Okay, almost done. Arc length. We kind of talked about the lengths of arcs and their relationship to angles already. But an arc, or dimension of the arc, which is different than an arc length. The measure of the arc is the same as the central angle. So if this angle was 30 degrees, what would the measure of the arc be? 30 degrees. The arc length is different. Arc length, I think the formula is down here. Arc length is a fraction of the circumference. Here it is. Right here in the box, that's the formula. The thing you need to know about arc length is theta has to be radians. It's pretty easy. You just take the theta and you times by the radius. So if I have a 30-degree angle here, and I know my radius is 5, we can find the arc length from here to here, which is a fraction of the circumference. But the theta has to be, in order to use this formula, theta has to be in radians. So we need to get theta into radians. Right now, theta is 30 degrees. How do I change 30 degrees into radians? Nope. Remember, 180 goes on the bottom. So we have degrees cancel out. What goes on the top? Pi. Okay? So 30 divided by 180. Do not type in the pi button. 30 divided by 180. Math. Enter. Oh. 1/6. So with the pi, it'll be pi 6. That's our theta. Theta is our angle in radians. So now we can pretty easily just plug right into our formula. Pi 6 times the radius. What is the radius? Nope, it's on the picture. Nope, it's on the picture. 5. So there are 2 ways to write this answer. 5 pi 6 is the answer when the directions ask you to be in terms of pi. Sometimes we want an exact value. Okay? That's the exact answer. Because it's not random. Once you type the pi into your calculator, the decimal goes on forever. So you'd be rounding the decimal. Okay? Another way the directions could ask is round to, I think your directions say the nearest 10. So if asked in terms of pi, you do not type the pi in your calculator. So it says round, then we do type the pi. So we're going to type in 5 pi divided by 6 and round the decimal. That's a calculator, 5 pi. 5 pi is above the division sign when that caret is in blue. 5 pi divided by 6. I need this decimal rounded. 5 pi divided by 6. Pi is above the caret, so it's the second caret. Second caret, the caret's right there. 5 pi, caret is right, oops, there it is. So second, you can see the blue pi symbol above it, divided by 6. Yeah? I added them to the problem. Okay, so what is our rounded decimal for the nearest 10? And what do you get? Good, thank you. 2.6. This is approximate length for the arc length. If we had a unit like inches, then we would say inches. Okay? But theta has to be in radians. We can do this mistake if people don't put theta in radians. The last thing on the next page is the area of a sector. Again, theta has to be in radians. There it is. It's almost like pi r squared, kind of. But pi is replaced by theta. Here's the formula. 1/2 theta r squared. Instead of pi r squared for area, it's 1/2 theta r squared. The theta has to be in radians. Okay, so let's practice this problem. Finding the area of this shaded sector. Notice it's not a perfect triangle. It's curved over here. Okay. What degree of measurement does that angle look like? Let's just, you think 20? Okay, so angle is going to be 20 degrees. In order to use the formula for area, you have to have 20 degrees in radians. So theta is 20 degrees. How do we change that to radians? Well, it has to be on bottom, because we need the degree. And what goes above the 180 degrees? Pi. So if you just always make sure you actually have a cancel. I have my degrees canceled, I want on top and bottom, then you should be set. So the pi will be in your theta. We just need to take your calculator and do 20 divided by 180. Math, enter, enter. Type it in. Grab the calculator behind you, please. Okay, can you type it in for me? Let me know what you get. 20 divided by 180. Math, enter, enter. 1/9. Good. So 1 pi 9. So that's our radian. Now we just type into the formula for area. 1/2 theta r squared. So theta has to be in radians. Theta was pi 9. R was, oh, we leave an R. This isn't stuff you just make up. It'll actually be on your problem. Last time we used 5. What do you want to use this time? 21. 21 might be a little too high. Okay, so 6. So the radius will be given on the problem. You don't actually make it up. So we're going to do a radius squared. Now, the directions will come in 2 ways. If it says, in terms of pi, you do not type the pi into your calculator. You should still have a pi in your answer. So we're just going to do 1/2 times 1/9 times 6, which you have to put parentheses around your fractions. So in my calculator, I would do 1 divided by 2 in parentheses times 1 divided by 9 in parentheses times 6 squared. Type that in. 1 divided by 2 parentheses 1 divided by 100 type this in 9 parentheses times 6 squared. Oh, this is a nice problem. Yeah, it would can go out. Since it's a positive, it doesn't really matter. It can go in or out. Okay. Remember, did you get that all typed in? Connor? Close. So in terms of pi would be 2 pi is the area, because the pi is still there. Now, if I ask you to round your decimal, that would be, what is 2 pi? We do 2 times pi. I already told you this decimal earlier. Approximately 6.28, so we, my directions on the homework now say around to the 10, so we say 6.3. So that's in terms of pi, and this one's a rounded decimal, depends on what your directions asked for. Okay? So, times 2, work on some of the extra credit. Those are your notes. Turn them in with the test. Keep your notes out. You don't put your notes away when you're doing homework. You shove your notes out right next to you when you're doing your homework. Okay, let's see if we remember how to do angles. You know, with this, let's see here. Probably the camera so you can see me do this. Now, if you notice, it says the circle ones are required and the other ones are extra credit. Oh, it doesn't say that. Sorry, I was meant to write that in. But you can see the ones that are circled. So, the circles are required, you don't write it in your stuff. The other ones are extra credit. Okay, let's look at number 5, an extra credit one. Okay, number 5, an extra credit problem. Let me really hard to type over here. There we go. Find the measure of the arc FG. How can we find the measure of that arc? Come just sit up, please. Okay. The corresponding arcs. Which corresponding arc? Okay, Dano? Rated? Will it be what? Sure. With a vertical arc created by the vertical angle. This, green is not the best choice. This angle right here is the central angle. What do we know about the central angle and its arc? They're equal. So if I know the measurement of this angle, then I also know the measurement of the arc. Notice right here we have a straight diameter. Do we know anything about this angle, F, in the middle, J? 40. So this smaller angle has to be 40. Isn't that a straight angle? The diameter is 180 degrees, right? So that's 140, and this one has to be 40. So the measurement of FG is equal to its central angle. So that's 40. To take the information around it to solve what was requested. It's just, for the arcs, it's just 40. For the angle, there's a degree. Okay, let's look at this one right here, number 7, another extra credit one. Find the length of each side, notice the directions in terms of pi. So pi should still be in your answer. You should not round pi. Okay, find the length of the arc. That's bolded. What's that formula that, since you still have your notes out, you should have at towards the end of your notes for an arc length. Theta R. And theta has to be in which form? Radians. So we're looking from here to here. Do we know that angle? That central angle? Yeah, it's right there, 225 degrees. So we can transfer 225 degrees into radians. How do we change 225 degrees into radians? Yep, pi over 180. The degrees cancel out. We need to use a calculator for 225 divided by 180. Math, enter. 225 divided by 180. Jada, can you do that for us? 225 divided by 180. Math, enter. What? Good. So we solve pi. So the 5 pi force. That's theta. So all we have to do is times 5 pi force by 13. 5 times 13. You're not excused. Sit down. It's 65 pi over 13. This is your answer in terms of pi, because the pi is still in your answer. And we know miles. Sorry, you should put miles with it. Okay. So give something runs, the other one's not to the extra credit. Please bring your calculator back and put it in order. I'm going to make sure it's actually in order, please. Thanks, Johnny. Need your calculator, please. Do you have calculator 5 over there, Lieutenant? Do you have calculator 5? Okay. Good.